In this session, we're going to talk about operating systems, give you a little feel for what they are, what they do. Operating systems do a number of functions, not all of which are listed here. One of the major things they do is control input and output. From external devices, they move data into memory, and to external devices, the operating system takes data in memory and transmits it outward. Memory that needs to be allocated to a program is done by the operating system. Operating system schedules CPU time or a priority of it for running the program. So some programs run with higher priority, others run with lower, based on what the program is supposed to do. Operating systems are responsible for system integrity and security. If you have ever signed into your computer with an ID and password, that's part of the function the operating system provides. Try to make it secure. There are many other ways that an operating system makes the machine secure. And as you're undoubtedly aware, it's not perfect. There's still breaches, there's still viruses that get in and cause trouble, etc. Some tasks need to run all the time. The operating system schedules those and monitors them, make sure they're running. And the operating system is really the key piece of software on the machine that allows multiple programs to run simultaneously. These system and application programs run at the same time. Some of the system type programs are communications programs, monitoring, various other tasks necessary to just keep track of what's going on. The system health is checked frequently, certain aspects of the system, machine and software, and errors get logged. Technicians or whomever can look at those and determine what's going wrong. Operating systems also deal with talking to other computers running operating systems. They communicate. Running multiple tasks simultaneously is actually a massive step forward in using computers. Up until that time, a machine would run one program at a time. And that was rather inefficient because most programs run rather slowly compared to what the CPU can do. So the CPU was sitting idle most of the time, and it was determined that that was a waste of money. So the ability to run multiple tasks at once soon developed into a hot area of research, and significant work was done on that. The idea of multiprocessing is that multiple processes can run simultaneously. A single core machine share the CPU across those tasks, each task getting a little bit of CPU time, task by task. So it appears that all of them are running simultaneously. On a multi-core machine can have true simultaneous operation of a number of tasks at once based on the number of cores. If you have a 4-core machine, then 4 applications can be running simultaneously. And then beyond that 4, it would do what's called that time slicing. Each CPU would give a little time to multiple applications so that many are running at the same time, 4 simultaneously, and everything else getting its time. Multi-threading is a different type of simultaneity. It allows a program to have multiple paths of execution. We will not get into that in this class, but when you develop GUI applications and some communications programs, you want multiple threads because certain threads will stop or block and not run at all. And you don't want your program doing that. If it's waiting for something, it'll stop. Something like user input. Multiple threads allow other pieces of the program to run at the same time. Interprocess communication, that is the talking back and forth between processes, either on one machine or across multiple machines, is rather tricky. It's much more sophisticated than what we will learn in this course, but it's a challenging area to grow into. Linux in particular provides libraries that allow programmers to easily access the interprocess communication aspects of the operating system, work with that. That said, interprocess communication programming is not trivial, but it's fun. A program does not directly talk to input and output devices. That may sound a little odd. When you type on the keyboard, giving information to your program, the program actually is asking the operating system, would you please read the keyboard and give me the information? Part of that is simple efficiency, as it says here, buffering. Buffering is a term for collecting data into larger groups before you actually transmit them. That saves a lot of overhead. It's much more efficient, but it does cause a few problems. For the most part in this course, we'll not worry about buffering. It'll just appear that our program reads the keyboard or writes to the monitor. In fact, the operating system is in between doing the real heavy lifting.